I'm going to give you an astounding result.
Astounding.
An astounding result.
So I'm just going to write down a little sum, and we're just going to see what answer it gives. 1
Plus 2
plus 3
plus 4
plus and I include all the natural numbers, so all the way up to infinity. So what do you reckon the answer to this is, Brady?
Well, I would say it would tend towards infinity.
Yeah, that makes sense, doesn't it?
The answer to this sum is, remarkably, minus a 12th. It's amazing. I mean, I first saw this result when I started learning a bit of string theory.
And what's even more bizarre is that this result is used in many areas of physics.
This is a very well-known string theory textbook by Joe Polchinski. As you can see, sort of quite early on, page 22, we have this statement here, which is that the sum of all, this is basically saying that the sum of all the integers, or the natural numbers, all the way up to infinity, is minus a 12. All right, so we're going to prove now, without getting our knickers in a twist with Riemann zeta functions, we're going to prove quite a simple way why the sum of all the natural numbers is indeed minus a 12. So to do that, we're going to do this in a number of steps. We're going to look at a few different sums. The first sum that I want to look at, I'm going to call it S1, and it's 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. That's the first sum I want to look at in principle. The second sum I'm going to look at is 1 minus 2 plus 3 minus 4, and so on. Carry on in that process all the way up. And the third one is, of course, going to be our one that we're really interested in, which is 1 plus 2 plus 3 plus 4, and so on. So we're going to evaluate all these three different sums. Now, the first one is really easy to evaluate. We need to attach a number. Now, clearly, what is the answer to this? Now, you stop this at any point. Okay, if you stop it at an odd point, you're going to get the answer 1. If you stop it at an even point, you'll get the answer 0. Clearly, that's obvious, right? So what number are we going to attach to this infinite sum? Do we stop at an odd or an even point? Well, we don't know. So we take the average of the two. So the answer is a half. There are other ways to prove that this sum is a half, by the way, which we can do if you want. But
No, there'll be a link. There'll be a link there because we've done it before.
Okay, good.
So you'll see the link there.
Okay, so this is a half, but I think intuitively that's the easiest way to see it, that you either get 0 or 1, and therefore you just take the average. So this is the natural number to attach to this sum. But once we know this, we're laughing, okay? Because from this, we can achieve everything that we want to achieve. The next step is to find out what this sum is. So what I'm going to do is, I'm going to take 2 copies of this S2. Okay, so I'm going to add it to itself. So 2 times S2 is equal to, well, let me just write it out. So I'm going to write it out twice. 1 minus 2 plus 3 minus 4, so on. And then I'm going to add to it itself, but I'm going to shift it along a little bit. So that's plus 1 minus 2 plus 3 minus 4, and so on. Okay, I've just taken 2 copies and added them together. But I've done it in a particularly nice way, in that I just push this one along slightly on the bottom. So now you see what you get. You take this one and this and this, and I get 1. So 1 plus nothing is 1. Minus 2 plus 1 is minus 1. 3 minus 2 is 1. Minus 4 plus 3 is minus 1, and so on. And I'm going to keep getting this pattern. So hang on a minute, I've just got back the sum that I started with, which I know the answer to. So half. Okay? So therefore I know this sum now. Because I just divide through by this 2 and I get a quarter. So now I know that this sum, this second sum with some where the signs alternate, is actually equal to a quarter. So this is my second remarkable result. Now I have everything I need to prove this crazy minus a 12 thing, right? Okay, so let's do it. I'm going to take this one and I'm going to subtract this one. Okay, so I'm going to subtract S2 from S. Well, let's write them out again. Okay, so I'm going to write out S first, which is 1 plus 2 plus 3 plus 4 plus 5, and so on. Okay, and I'm going to subtract S2. So that's minus, okay, and let me just put a bracket in now because I'm going to minus all of this. 1 minus 2 plus 3 minus 4, and so on. Okay, okay, 1 minus 1, what's that?
0.
0, yeah, exactly. So I get nothing from that bit. 2 minus minus 2 is 4. Okay, 3 minus 3, 0. 4 minus minus 4 is 8. And so on. And the next one, I'm going to get, from the 5s, I get nothing. From the 6s, I get 12, and so on. And it proceeds in that way. And now you can see we're almost there now, right? Because look what I've got here. I've got 4 plus 8 plus 12. If I take a factor of 4 out, it's 4 times 1 plus 2 plus 3. Okay? It's my sum that I wanted. So now I've got a formula for my... So this is just 4 times s, which is my sum. So now I just solved this equation, right? Because I know what S2 is. So I have now the expression S minus, because I know what S2 is. S2 is a quarter, is equal to 4s. Okay, I take s from either side, so I get minus a quarter is equal to 3s, which implies that s equals minus 12. So now do you believe me? That's amazing. I love it. It's amazing. Who'd have thought it?
Tony, if I got a calculator out and wrote 1 plus 2 plus 3 plus 4 plus 5, and I sat here until the end of everything and then pressed equals, would I get minus a 12?
How do you mean the end of everything? You can't do it to the end of everything, can you? So, see, the point is, I know this looks like a bit of mathematical hocus pocus sort of thing, but actually, in truth, it's not. And I'll tell you why we know it's not. We don't, and I know you think I go on about physics too much, but we know it's not because of physics, because these kinds of sums appear in physics, and in physics we don't get infinite answers. It's amazing, and it's just, do you know, I was trying to come up with an intuitive reason for this, and I just couldn't. To be honest, it's just, you have to do the mathematical hocus pocus really to see it, and then you just have to believe that you're not measuring physical infinities in nature, and then those two facts together, I think, give you confidence in this result. But it is clearly counterintuitive, and it's counterintuitive because, you know, intuitively you just want to stop the sequence, and the minute you stop the sequence, then all your intuition for this result goes out the window.
So if I do 1 plus 2 plus 3 plus 4 plus 5 and I go up to a Googleplex,
you'll get a big number. Yeah, you won't get anything like minus a 12. You have to go to infinity, Brady.